Sorry, everyone.
We are live now. Namaskar and a very warm good evening to everyone present here. I welcome all our viewers to our today's evening session of the Virasat Talk program, which is also our 169th episode of the Virasat Talk series. I feel extremely honored and privileged to welcome Dr. Blinkhorn, uh, sir, Dr. Jimbob Blinkhorn, sir, to our today's evening session. Uh, ex- Extremely welcome to you, sir. Uh, we are today with us. We are joined with a esteemed panel. We are joined with our chairperson, Dr. Anantashutosh Dwivedi, sir, our Dr. Astha Dibyopama ji, and Sonal Dhiklezi. I welcome all of you to our today's evening session. This session is live on the Facebook, YouTube, and Twitter channel of Heritage Society. I request all our viewers to join as soon as possible and connect with us to join our today's evening session. You may also post comment, your questions, your queries, feedback during the live session to connect with our esteemed distinguished professor, Dr. Blinkhorn, sir. Dr. Blinkhorn will be speaking today on the topic Into the Monsoon: Modern Human Expansion in the Thar Desert. Uh, Without taking much time, I may now request Dr. Astha Dibyopama to kindly present the welcome address and officially inaugurate the today's evening session.
Thank you so much, Azad. A very good evening to all. Before introducing our distinguished speaker, first I would like to thank Heritage Society, specifically Dr. Anantashutosh Dwivedi ji and Azad ji and entire the Heritage Society family for including or making me part of their family. Thank you so much. Extremely grateful for this gesture. Now I will come to the introduction of our distinguished guest. We are extremely thankful to our speaker, Dr. James Blinkhorn, for giving us opportunity to keep his talk on the Heritage Society platform. Dr. James Blinkhorn, currently the Fieldwork Director of Pan-African Evolution Research Group at Max Planck Institute for Science of Human History. He has spent almost 20 years studying and researching on the Paleolithic culture of South Asian region. In the past, he has undertaken fieldwork in the Andhra Pradesh and Madhya Pradesh, and alongside the colleagues from the MSU Baroda and Anna University Chennai, he has ongoing research project. For that, he conducts the fieldwork program in Gujarat and Rajasthan. His researches on the Thar Desert are in the form of well-published research papers. There are many research papers he has published. For example, like Middle Late Pleistocene fluvial activity in the central Thar Desert. Another is the Middle Paleolithic occupation in the Thar Desert during Upper Pleistocene, the signature of modern human exit out of Africa, and many more research papers he has published regarding his work in the Thar Desert. And that is very exciting for the researchers like us. And he has also worked on the few of the very well-known prehistoric cave sites like Fahian Lane Cave and Kitilgala cave site, which is situated in the tropical evergreen rainforest of the Sri Lanka. So his work from Sri Lanka is equally exciting. This talk will be extremely beneficial for the scholars who are working in the different parts of the Thar Desert, whether it is the Jodhpur or Jaisalmer part of the Rajasthan, or the various regions of Gujarat, or whether it is the region which is part of the Pakistan region. So, uh, on the behalf of the Heritage Society, I welcome Dr. James Blinkhorn, and we are extremely grateful to you. Like the scholar, like you have spare time for us, and you came to our platform to enlighten. This is not for the scholars, archaeologists. It will be very beneficial. Apart from that, the public also, general public also, they are going to benefit it from your talk. So instead of spending much time on the introduction, we should invite our honorable speaker. Thank you so much.
Thank you, Astha.
Great.
Thank you so much for welcoming our distinguished speaker. Without taking much time, I will request Dr. Blinkhorn, sir, Dr. Jimbob Blinkhorn, who is currently Fieldwork and Director of Pan-African Evolution Research Group, Max Planck Institute, Germany. I request Dr. Blinkhorn to kindly begin the session.
Oh, well, to start with, thank you very much for the invitation to talk to your group. It's very exciting to have these opportunities these days to be able to speak, particularly to both the academic and a non-academic Indian audience. I'm very grateful for this opportunity. And thank you very much for the very kind introduction as well that you've given me to my talk. I'm going to start talking quite broadly about human origins and expansions to suggest that the western margin of the Asian monsoon system marks a key ecological threshold for human dispersals. For much of the talk, I'm going to focus in more detail on my own work in the Thar Desert in Rajasthan and Gujarat in western India that marks this monsoonal threshold. And then I'll finish the talk by briefly putting these results into their broader regional context. So Homo sapiens, our species, appear in Africa around 300,000 years ago, broadly contemporary with the appearance of the Middle Stone Age. This is where we see the replacement of assemblages dominated by large cutting tools and characteristic of the Acheulean. And they're replaced by those focused on flake-based tools, use of Lavallois technology, alongside long-distance transport of raw materials and the use of ochre. Now, not so long ago, significant emphasis was placed on Eastern Africa as a potential source region for our species. But it is now increasingly apparent that Homo sapiens is unlikely to stem from a single region in Africa, and rather that there is a mosaic appearance pointing to substructured populations across the continent with varying patterns of connectivity through time. So while our perspectives on the origins of Homo sapiens within Africa are changing, we remain very clearly an African population. Within the time frame that I'm looking at here, Homo sapiens were just one of many hominin populations, and with the exception of Homo naledi in southern Africa, the rest were Eurasian populations. And it's a region we see considerable diversity. Now, an example would be the Neanderthals. They're perhaps the most famous and best known of these populations, but with a wider range of fossil and genetic populations being identified even in the recent years, it's clear that Eurasia was a complex demographic landscape. One population that isn't talked about as much is the late Middle Pleistocene hominin from India. Now, the single pre-sapiens fossil that we have from the region, and I think partly it's not discussed as much because it is the only site we have from the region, and partly because of the mosaic of morphological features that it preserves. Now, Sheila Arthrea, who has undertaken the most detailed comparative studies of this specimen, characterizes it simply as a mid-Pleistocene Homo, emphasizing that it has traits comparable with contemporaneous Eastern and Western Eurasian hominins. But not that long ago, Eurasia bustled with a very diverse hominin population. But today it's only ourselves, Homo sapiens, that remained. So what changed? Well, as we know, at some point, modern humans have expanded across the world and replaced all of our closest relatives. Now, these two maps provide a quick snapshot of the alternate approaches academics have used to assess the timing of this. Now, the widespread distribution of our species across Eurasia and Sahel by 45,000 years ago, and shown on the right-hand side, is largely uncontroversial. Now, the presence of Homo sapiens burials in the cave sites of Sri Lanka fits right at the start of this phase. In mainland South Asia, in contrast, fossil evidence for Homo sapiens is restricted until after the last glacial maximum, so around 16,000 years ago. So this is a major confound to studying human dispersals in the region. Now, it appears that everyone alive today shares heritage with populations that expanded around 60,000 years ago. But a range of evidence points to earlier expansions of our species. And this includes from the archaeological record in Australia, dating to 65,000 years ago, fossil records in Eastern Asia from 70 to 100,000 years ago, well-established evidence from Southwest Asia, pushing the presence of our species in that region to at least 120,000 years ago, and recently there's evidence pushing back even further. Now, when we talk about these expansions, we typically use the term out of Africa. It provides a simple description of our shared African origins and the demographic changes we see across Eurasia as Homo sapiens replace numerous other populations. Now, out of Africa models place focus on narrow points of geographic contact between Africa and Eurasia as key thresholds to examine expansions, particularly as I'm highlighting on the slide with my mouse, the narrow land corridor across the Sinai Peninsula. Now, from the top down, the split of Africa and Eurasia appears to present natural geographic units to use. But to what extent do they provide the framework to explain the processes of human expansions? How notable would this transition from one to the other have been for Pleistocene populations? Now, for both early and late dispersal models, it is argued that expansions followed a southern dispersal route across southern Asia to Australia prior to northward expansions into the higher latitudes of Europe and North Asia. And this is consistent with both the fossil and genetic records. Looking along this southern route, we can identify a stark change in ecology between the arid landscapes of the Sahara, Arabia, and the Iranian Plateau, to the visibly lusher and greener landscapes starting in South Asia and extending to the east. And it is this sort of change that is of real interest to me. Change that is palpable and obvious, not just from the top down, as we can see here, but that it would have been obvious on the ground at a human scale too, a scale at which could affect how you make and use stone tools to engage with changing ecological resources. So the change I'm really talking about here is, of course, the monsoon. Now, these are climate models that show the most extreme aridity on the left and extreme humidity on the right during the last glacial cycle. Now, during humid phases, seen on the right, expansion through the deserts, the Sahara and Arabia, would have been possible, but in arid phases, it wouldn't have been possible to survive. What's notable in both scenarios, however, is once you reach South Asia, you find landscapes that are permanently habitable. Now, with the monsoon, not only do we see a change in the scale of humidity, but also in seasonality, with the southwest monsoon delivering the majority of South Asia's precipitation in the summer months, as opposed to the weaker winter rainfall seen in the desert belt. So crossing the monsoonal threshold, you encounter greater humidity and a different pattern of seasonality, both which could be readily felt on the ground and at a human scale. It's the influence of the monsoon and its seasonality on ecology that results in monsoonal Asia forming one of the world's major biogeographic zones, here identified by Holt as the Oriental Zone. So expansion into South Asia involves crossing a major ecological threshold. We see different patterns of rainfall and seasonality impacting plant life, impacting animal life, and ultimately impacting us. Now, there are two other changes that also occur in a similar location. Firstly, India is surrounded by mountain chains, which are a stark contrast to the lower hills and broad valleys of the subcontinent. And this is connected to a second change, a change in geology. Paleolithic populations, a change in geology would be readily identifiable as it changes the raw materials you have available for making tools day to day. Combined, this means that I'm changing from examining questions of human dispersals in an out of Africa framework and rather use an into the monsoon framework. Taking a step in here, I've just plotted a number of records of monsoonal intensity on the right-hand side, with a Bitu cave record, marine records from the Bay of Bengal and the Arabian Sea, as well as some high latitude records. Now, the monsoon is such a defining climatic feature of the Oriental Zone, as influenced by both the northern and southern hemisphere patterns of glaciation. Glacial maxima occurring in this phase broadly match with weak monsoons, and strong monsoons are broadly evident in interglacial phases. So we can see these peaks here. But other patterns of other orbital features, such as precession, also have significant impacts on insolation in the monsoon system. And what this means is that we see some slightly different patterns of climate change in low latitudes, with strong monsoons evident in glacial phases. An example would be at the start of marine isotope stage 3, in this period here, where you can see peaks of monsoonal intensity that equal or even rival those in the last interglacial phase. It's these fluxes in monsoonal precipitation that would have been felt very directly on the ground. As it stands, it's these regional records that provide some of the best constraints and patterns of monsoonal intensity through time, but they are distant from the landscapes occupied by past populations. So looking to some terrestrial records, and in contrast to some other areas of the subcontinent, the Thar Desert has quite a rich paleoenvironmental record for the late Pleistocene. Combinations of sand dune records, riverine records, and lake records, they document changes in climatic conditions over the past 200,000 years to the present. And this broadly fits in the patterns that I've just described, with peaks of monsoonal intensity happening during the last interglacial as well as at the start of marine isotope stage 3, and then declining towards the last glacial maximum before recovering to modern levels. Now, I'd like to highlight this paper that we had published last year, and it indicates that in the past, a substantial river flowed through the central Thar Desert, close to Bikanir. Now, this is something that has been evident from satellite studies from at least the 1970s, but this is the first time we've examined one on the ground. And this is at the site of Null Quarry, as you can see on the map on the left. Now, in the middle, we've zoomed in, and you can see the location of the site adjacent to this linear feature showing up in blue, cross-cutting the modern drainage basin, it's marked in grey. That's indicative of some past drainage disruption. Working at the quarry at the site that you can see in the picture in the bottom right, we're able to sample fluvial sediments and dating them using luminescence dating, highlighting that there are multiple phases of fluvial activity in marine isotope stage 6 and marine isotope stage 5. Now, this is a critical time frame for eastward human expansions across monsoonal Asia, as well as for understanding the Acheulean to Middle Paleolithic transition. It appears that we've got a substantial river crossing the Thar Desert. Now, as an unusually fortunate analogy, enables us to better characterize how changing fluvial landscapes such as this could have affected habitability in the area. The modern Indira Gandhi Canal draws water from the Sutlej and flowing into the central Thar Desert, enabling agriculture where monsoonal rainfall is either too low or unstable. Now, this canal has led to some unanticipated side effects for regional ecology. Where water leaks from the canal, it directly supports a broad range of flora, and this in turn has some significant impacts for habitability at the core of the desert for birds and large mammals alike. I've just indicated that there are studies showing how nilgai populations, as an example, are flourishing there now. So it really gives us a nice characterization that with the presence of additional fluvial channels across the desert, they can enable flora and flora to thrive, and potentially humans too. Now, while we see much of the debate surrounding the Gagra-Hakra River, shown in purple on the left, relates to its potential role in the rise and fall of the Indus civilization, dating shows that it was an active river between MIS 4 and 2, between about 80 and 12,000 years ago, taking water from the Sutlej across the central desert, much in the same way that the Indira Gandhi Canal does today. So although that river system plays a big role in the debate about the Indus civilization, for me, perhaps it has a bigger role to play in talking about the Paleolithic of the region. Now, on the right, I'm extrapolating from satellite studies, which have investigated earlier channels such as the one that we've identified at Nile Quarry, to suggest that a comparable river channeled water from the Himalaya across the Thar Desert prior to migrating the Gagra-Hakra course. So I've begun to question the extent to which this fluvial landscape provided a vital buffer for eastward expanded populations, and the continuous accessibility of water may have provided a vital lifeline at the eastern margin of the desert belt, providing security against the risks of aridity. This stability provides the basis to engage with new resource bases, new patterns of seasonality, and successfully adapt to monsoonal landscapes beyond. So turning to look at the archaeological record, I'll just start with a quick point about terminology. Now, there's been a range of terms used to describe the broadest Paleolithic phases in South Asia, most of which reflect a very similar tripartite division between the Lower Paleolithic, almost exclusively Acheulean, the Middle Paleolithic, and then the Late Paleolithic. This is a term that's used elsewhere in monsoonal Asia, introduced into the Indian context nearly 20 years ago, recognizing that we don't really see an Upper Paleolithic as it is manifest elsewhere in Eurasia. Now, as I've already highlighted, at a global scale, models for human expansion can broadly be split into two. Now, in South Asia, this has typically resulted in a split of models in which one, humans expanded before 60,000 years ago, associated with Middle Paleolithic technology, but with a presumed technological break with the later Acheulean assemblages, and demonstrating continuity and gradual development of late Paleolithic technologies. That's what I'm highlighting in this middle line. And then we have models for expansions after 60,000 years ago, where continuity is emphasized between the late Acheulean and the Middle Paleolithic, with a technological break associated with the arrival of humans introducing late Paleolithic technologies. So we have these two alternatives. So I'm going to move now to talk much in more detail about the Paleolithic archaeology of the Thar region. Now, like much of South Asia, there's a long history of research here, stretching back into the 19th century, and a vast number of sites have been identified, but the majority comprise undated surface sites. When I started working in the region a decade ago, only 16 June yielded dated and excavated Paleolithic assemblages, with the rest of this data perhaps easy to overlook. But I felt uncomfortable dismissing this wider body of evidence out of hand. So what you see on the left and right are the results of a cluster analysis. These results show that Acheulean assemblages can be readily differentiated from other assemblages, potentially supporting a major cultural break. And while there are some discrete elements to Middle and Late Paleolithic assemblages, there is a lot of overlap between both in terms of the stone tool types they present and the constellations in which they appear in assemblages, here supporting cultural continuity between the Middle and Late Paleolithic. So focusing in on the dated and excavated sites, we can start with Singhi Talab. This site was excavated in the 1980s by a team led by V.N. Misra, who identified 3 Acheulean horizons at the site. Now, there's been some debate in the literature about potential dating of this site, but based on the records elsewhere in the subcontinent, it's fairly safe to assume this is likely to date to the Middle Pleistocene. Most focus on the archaeology at the site is on the large cutting tools, supporting the Acheulean attributions of the larger assemblages, and comparative studies by Kerry Shipton suggest comparability with other older Acheulean sites in the region. Now, a unique feature of this site is the recovery of a small collection of monopyramidal quartz crystals, shown in the bottom right, associated with this Acheulean toolkit, and they're considered to be manuports. So this gives us a slight, albeit obscure, insight into Acheulean life beyond stone tools themselves. Now, moving about 5 kilometers away, we have the site of 16 June, another site excavated by V.N. Misra, and the first reported from India with lower, middle, and upper Paleolithic horizons, as well as a Mesolithic horizon, integrated with the use of chronometric dating. So this was really a key achievement. As you can see from the photo, this was a really significant undertaking. The trench reached about 19 meters in depth, with 30 square meters opened up, recovering what was first identified as an Upper Paleolithic assemblage based on the age returned from radiocarbon dating of 26,000 years ago. Now, on re-examination, the sequence isn't so clear-cut. A recent reassessment identifies these main assemblages as Middle Paleolithic, and is now associated with dates ranging between 80 and 40,000 years ago. There are older occupations that are contemporary with the river flowing at Nile through the central desert, but we are unable to clearly assign them to either the Middle Paleolithic or the Acheulean. Staying in broadly the same vicinity, about 50 kilometers down the road, is the site of Katoti. On the left is a photo of the landscape I took nearly a decade ago with my collaborator, Professor Hema Thar. Over a couple of papers, we have documented the sequence with a high proportions of C4 vegetation associated with the lower fluvial phases, suggesting a period of strong summer monsoons. The upper Aeolian sediments are associated with C3 vegetation types that are likely to have existed under weaker monsoonal conditions. We recovered 3 assemblages with little taphonomic alteration, as well as 2 potentially reworked assemblages, which all date between 96 and 45,000 years ago. We attribute all of them to the Middle Paleolithic, based on the presence of alternate lava reduction strategies and other forms of prepared core technologies, as well as a range of both simple and more formal retouch tools, most notably the presence of tanged and shouldered points. Now, we've been able to conduct a field season to extend our excavations at this location, supported by funding from the Leakey Foundation, but much of this has been caught up in COVID-related disruption. So while it's a little too early to talk about some of the analytical outcomes of this work, I'll ask you to watch this space. Now, moving further south towards the Gujarati coast, I've been working with a team from MSU Baroda in collaboration with Professor Ajit Prasad. The region you can see here in the larger map is Kutch, and I've seen one single Paleolithic survey about 50,000 years ago, but it was enough to highlight the potential of this landscape for more work. Now, another key factor attracting us to work here is the proximity of the coast, as coastal routes have played an important role in alternate dispersal models. We undertook survey work in a large number of Kutch's drainage basins, finding widespread evidence for Middle Paleolithic occupations associated with late Pleistocene sediments. In contrast, late Paleolithic technologies were entirely absent in these late Pleistocene contexts and only found on the top of modern or Holocene deposits, failing to support key hypotheses posed in coastal dispersal models. Now, we've been conducting more intensive investigation at one of these sites we've identified at Sandav in the Naira Basin. In the photo on the left, you can see our first section of the site, with Avi Mukherjee in the midst of sampling, where we exposed the uppermost of 4 major sediment units of the site, shown schematically in the middle, with that white carbonate-rich deposit marking the top of Unit 2. Stable isotope work by Patrick Roberts has helped us to resolve elements of the ecological sequence, again indicating that the main artifact horizon we've recorded is associated with high proportions of C4 plants, and again likely correlating with enhanced summer monsoons. And working with Julie Durkin, we've dated this horizon to around 114,000 years ago. Now, amongst the artifacts we've recovered, one stands out in particular and is shown in the top right. This example of a tanged point made on beautiful green siliceous material. Now, again, we've been back to work more in this landscape and hope to be able to expand both the artifact collections from this site, as well as further constrain the chronology and geomorphological evolution of the landscape in the future. Finally, one of the key late Paleolithic sites in the region, first identified by Bridget Olchinen and her team in the 1970s, is Bulapushka. The photo on the left shows the location of the site in the Pushka Valley, a key pass in the Ara Valley range. Now, the artifact assemblages recovered from freshly eroding dune horizons, allowing them to be readily tied into a stratigraphic framework, But these deposits were not dated until the 1990s, and the two lines of evidence were never integrated. So a couple of years ago, I did a new study of the lithic technology and combining published evidence. The results suggest that there are two groups of assemblages, broadly split between an older group dating between 27 to 22,000 years ago, and the younger group dating between 16 and 13,000 years ago. Some elements of the technology are precisely what I might expect. They show a predominant focus on blade or bladelet production, the inclusion of burins, and some backed pieces. But what was notable, and particularly in the older group, is the continued use of production strategies that already existed in the region in the Middle Paleolithic, most notably Lavawa technology. So as a quick summary of the Paleolithic evidence from Western India, we don't really have any good chronological control on the Acheulean in the region at present. The available dates present either minimum ages or are perhaps unreliable. Although typified by the presence of bifaces and cleavers, there's the potential presence of alternate core technologies and engagement with non-functional material culture, so these crystals, that suggests there's still greater complexity to be revealed here. The Middle Paleolithic appears from 114,000 years ago and lasts until at least 43,000 years ago. This includes classic features such as Lavawa technology, alternate methods of point production, as well as the rare presence of bifacial tools at a much smaller scale than those known for Acheulean pieces. So shown in the middle, this tiny miniature biface from Sandak. Our surveys have failed to support models predicting the early appearance of late Paleolithic technology along the coast, and the occupations of Buddha-Pushka, dating from 28,000 years ago onwards, show the combination of a focus on smaller blade technologies with the persistence of prepared core methods from the Middle Paleolithic. So zooming back out and thinking about when humans first crossed the monsoonal threshold, well, the absence of fossils from the key time frame of interest means we must extrapolate from changes in material culture. While the chronology of the Acheulean isn't well constrained in the Thar Desert yet, our work in the region over the past decade has illustrated the Middle Paleolithic technologies appear in the region at the same time that we see occupations of Southwest Asia by Homo sapiens, and span the time frame in which they appear in Eastern and Southeast Asia, appearing in Australia, and as they begin to expand further north. Middle Paleolithic technologies remain in use in the Thar Desert within the time frame that Homo sapiens are widely accepted to be widespread across the Old World, with late Paleolithic technologies not apparent at the monsoonal threshold until the start of marine isotope stage 2, 28,000 years ago, showing elements of continuity with preceding technologies. So whether we look at early or late dispersal timeframes, it's Middle Paleolithic technologies that are in use in the Thar Desert, suggesting that at some point they were certainly used by Homo sapiens, our species here. The earliest appearance of the Middle Paleolithic at the monsoonal threshold fits with interregional evidence for the time frame of early dispersals here. Now, this pattern is not isolated when we look at a regional scale either, but there is some diversity too. India is notable for hosting the youngest Acheulean populations, dating to between 140 and 120,000 years ago in the Middle Sun Valley. A paper on these sites by Chris Clarkson and colleagues last year documented the appearance of Middle Paleolithic technologies here by around 80,000 years ago, and at around 48,000 years ago, we see them replaced by late Paleolithic technologies. Now, this matches very closely with a pattern shown by earlier work by Chris with Mike Petralia and Ravi Koruseta in the Jureru Valley, where a comparably young Acheulean occupation is seen, replaced by Middle Paleolithic technologies between 80 and 34,000 years ago, with a gradual local appearance of late Paleolithic technologies appearing from 35,000 years ago. Now, notably, in both cases, Middle Paleolithic artifacts are shown to closely compare to technologies used by modern human populations in Africa, Southwest Asia, and Australia, supporting their associations with Homo sapiens in India. Elsewhere in India, some of these patterns are also apparent, but the nature of the transitions are not so well constrained. For instance, in central India, we see evidence for broadly comparable ages for young Acheulean occupations, Middle Paleolithic assemblages appearing from around MIS5 and late Paleolithic assemblages appearing from 44,000 years ago. Similarly, at Bundala on the southern Sri Lankan coast, a Middle Paleolithic occupation dates to 80,000 years ago, with the appearance of late Paleolithic technologies at sites like Phar Hien, revealed by work by Oshan Weddergay and team, dating from 48,000 years ago. A study by Laura Lewis has shown that late Paleolithic technologies in Sri Lanka are noticeably distinct from those in India, differing from those in Africa, suggesting and supporting their mosaic origins and perhaps local innovation regionally in different areas of South Asia. So across South Asia, Middle Paleolithic technologies with shared characters appear overlapping the time frame of early human expansions across the continent. And in contrast, late Paleolithic industries appear asynchronously with mosaic technological characteristics. Now, this overall pattern, however, is confounded by recent reports from Pan-Afican by Akhilesh and Shanti Papu's team of a Middle Paleolithic assemblage dating to 385,000 years ago. Now, this brings up a lot of interesting questions that demand a pivot away from a focus on the origins of the late Paleolithic to look at the later Acheulean to Middle Paleolithic transition in more detail. Just summing up, I'll make 3 quick points here. Firstly, I don't see any reason why South Asia couldn't have been a centre for technological innovation in the Middle Pleistocene. And this finding demands we examine the factors that may promote innovation amongst the earlier Acheulean populations. Secondly, and on a related matter, South Asia is large and ecologically diverse. So it's plausible that populations in different parts of the subcontinent use significantly different toolkits. So this finding demands we question not only why could there be an early Middle Paleolithic, but why Acheulean technologies persisted so late in some areas and not in others. Finally, if modern humans expand across the monsoonal threshold using Middle Paleolithic toolkits, it is feasible that they may have encountered another Middle Paleolithic using population in South Asia too. How would we look to differentiate them from one another? Now, hopefully these questions I've just raised point to a couple of things. That there is the potential for discoveries in the next couple of years to significantly change how we think about human demography and dispersal into South Asia, and that these results can be globally relevant for understanding what happened when Homo sapiens met other populations as they expanded across Eurasia. And finally, they further emphasize the importance of examining ecological, behavioral, and potentially demographic transitions across the monsoonal threshold. So thank you very much for your attention today, and again, thank you for the invite to talk. I'd just like to thank, in particular, 2 of my colleagues who've supported my work over the last decade, Professor Hema Achithan and Professor Ajit Prasad.
Thank you, Dr. Blinkhorn. Thank you so much for this extremely well-researched, insightful, and thought-provoking lecture and presentation. Thank you so much, sir, and many congratulations to you and your team for this great research in Thar Desert. Before we move on, I may once again invite all our viewers and our distinguished panelists, in case if you have any queries, and if they're allowed, then we may take some of those.
Please. Please.
Astha ji, we are unable to hear you. I think your mic
Hello.
is, please unmute. Please.
Am I audible?
Yes, you are audible.
Okay. Many thanks, Dr. James Blinkhorn, for very enlightening or very informative lecture. Actually, I have one question from like my study area at Jodhpur district when I was working there. So there are, if I see the prehistoric part of that Jodhpur district, we have like so far the Professor V.N. Mishra, he has worked, and Alchin, and there are some prehistorians or geoarchaeologists from Deccan College also, they have worked. So overall, if I see the prehistoric sites from the Jodhpur district, so there are many lower Paleolithic sites we have. We have also good number of middle Paleolithic sites, Mesolithic sites also. But there are only the two, or right after my research, there are four upper Paleolithic sites are there. So what is the what could be the reason behind this? Like getting the very less amount of the upper Paleolithic site in the Jodhpur region, because that northwestern part of that Jodhpur district also falls under the Thar desert area.
Fantastic
Yes.
early work in this region. You can hear me?
Yeah.
Yes, please.
So, of course, yeah, V.N. Mishra did some exceptional early survey in the region. He really highlighted quite how rich the Middle Paleolithic record is. And if we think of now, we've been able to put the Middle Paleolithic into a chronological framework, that we see much of the Middle Paleolithic occupation in the Thar Desert spans from around 114 to about 43,000 years ago. So these are phases when we're seeing some quite intensive monsoons. This, you can imagine the Thar Desert would be perhaps greener than it is today. From around 44,000 years ago in South Asia is when we start to see what I'd term late Paleolithic technologies. And from this period onwards, we start to see a deterioration of the environment. So the monsoon is getting either weaker, more unstable, or more unreliable. And it's also at a time frame where in the Thar Desert, we see sand dune mobility starting to pick up. So one of the reasons I think that we see a lot less evidence for human activity at the start of the late Paleolithic time frame is environmental, that the Thar Desert would have been drier, it would have been less hospitable as you have much more sand dune mobility. And then I think, again, when you look in the region, a lot of what were previously called, have been called LSA assemblages, as well as Upper Paleolithic, a lot of them are very young, and they date after the last glacial maximum, some of them right at the start of the Holocene. So again, it's a period where the monsoon would have been stabilizing, becoming more intensive, making the region a more attractive place to inhabit again.
Thank you so much. It is like very important. Your research is very important. Like scholars like us who are working in like a very small part of the Thar Desert we are covering, so we can actually put the research in the global perspective. Like considering your research and taking the help from the whatever the research you have done. So extremely enlightening. And thank you so much for wonderful talk.
Thank you, sir. Any more queries?
I think
If no, then if Dr. Blinkhorn would allow me, then I may go on with a very small query, maybe out of ignorance, it may be not completely correct. Um, I was pondering on this climate change induced human migration that was prevalent in the Thar Desert, and then the eastward shift of the human migration in prehistoric age that was happening. I mean, it was slowly and slowly shifting towards monsoon Asia, and Thar being located in between of the arid zone and the monsoon Asia. The different kind of behavioral changes that were coming up there. I was thinking in terms of uh, uh, a little slightly different location, Rajgir, where we recently discovered a couple of Paleolithic sites, and it has been continuously reported there in Rajgir, near close to Nalanda, in Gangetic Valley, Plain region. Uh, so, uh, how these networks of human migration was happening, and then uh, 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 like this area of Rajgir and Nalanda and this region has remained most part of the time out of the larger discussions on prehistoric human migration. So how do you see, Professor?
Yeah, so I think thinking about human populations expanding and a relationship towards environment, well, partly, there are some conditions which are going to prohibit human expansions, and that's what I'm highlighting. Very arid phases, such as in the Sahara and the Arabian deserts. Sometimes it's just simply too arid for human populations to expand. But when you have conditions which are possible for human expansions, then you see a slightly different engagement between environmental change and human populations. And we've got to think that some of the timescales that we might be looking at these expansions on, we quite often see arrows pointing large ways across going long distances across the map, whereas actually we've got to remember that these were people on the ground, and it's changes in those small scale landscapes, which I think is why I'm particularly interested in this threshold between the deserts and the monsoon. Thinking about the Gangetic Valley, one of the most complicated things there as a Paleolithic archaeologist is the amount of sediment deposition in the Holocene. So as a Paleolithic archaeologist, I'm always looking for those contexts in which I can very rapidly access sediments dating to the late Pleistocene or older. And so that's where you have some of the large river valleys make that very complicated, either because the river erosion and deposition is recycling these sediments, or simply there are these older landscapes there, but they're just buried. So that's where, in some ways, a lot of Paleolithic research around the world will focus on sites such as caves, because quite often they have these different patterns of sediment formation which might help preserve and allow you to access older deposits more quickly.
Thank you, sir. Thank you so much, sir. I was also thinking on, like you pointed out, about the certain archaeological findings in Thar which points towards the existence of a river in that area. So, do you also find any any relation of it with this mythological river of Saraswati, which came up frequently in Indian media and everywhere, of the existence of the mythological Saraswati river from the area of Gujarat, Thar, and other regions? Do you find any relation?
So, I think when you're talking about rivers in the Thar Desert, a lot of people very quickly suggested it was the Saraswati River. And in fact, the same argument has been made about the Gagra Hakra as well, a river that we now know was flowing between around 80,000 and 12,000 years ago. The site that we identified at Nal is most likely just an earlier course of the same river system that migrated westwards until not so long ago. You see the modern Sutlej flowing more directly into the Indus Valley. So it's a part of this broader pattern of just fluvial migration in the region. I'm certainly not well versed enough in some of the aspects of mythology here to know quite how and where it might articulate with arguments for it being the Saraswati River, but I think it's, for me, looking at this slightly deeper time scale and looking at this broad process of river changes, suggesting that perhaps at least over the last 200,000 years, up until about 10,000 years ago, rather than just having the Indus coming down and crossing the most arid region, for 190 of 200,000 years, we had a second river coming down, flowing across this region.
Thank you, sir. Thank you so much, sir. Is there any more question or any more suggestion query?
Okay, one more thing I wanted to ask from Dr. James Blinkhorn. Will you suggest any recommend your any publications for a researcher like us who are working in the this third desert part of the like Rajasthan and Gujarat? Will you recommend and also the question I have asked you about the why less amount of the upper Paleolithic sites are there in this Jodhpur district of Rajasthan. So, will you suggest recommend us some references or some reading?
I mean, so I had a paper that was available online last year and officially published this year in Quaternary International, which really just built on my PhD, which I believe is available online as a PDF as well, in which I'd synthesized every site reported as Paleolithic from the Thar Desert region. So by which I'm mostly talking about Rajasthan, west of the Aravalli Mountains, and some bits of central northern Gujarat, Saurashtra and Kutch. I have most of my papers are up online at jblinkhorn.com, so it should be accessible there. But this paper, it goes over about 900 reports for the Paleolithic sites in the region, breaking them down, and there's also a supplementary information, a database just of the locations and the names of the sites.
Okay, thank you so much. Thank you so much.
Thank you, sir. Thank you so much, sir. I may now request our Honorable Chairman, sir, Dr. Anantashutosh Dwivedi, sir, to present final remarks, presidential remarks. Thank you.
Thank you very much, Azad ji. First of all, I would like to congratulate Heritage Society Assam Circle and Maharashtra Circle for organizing this highly informative session. Now, I would like to thank our distinguished speaker, Dr. Blinkhorn, for giving this wonderful talk about the human expansion in the Thar Desert. As our welcome speaker, Dr. Astha ji already introduced regarding the outstanding works done by our today's speaker, Dr. Blinkhorn. You have worked for past 2 decades researching about the Paleolithic South Asia and the global expansion of Homo sapiens, and your work has encouraged our researcher from around the world. Today's talk was tremendous, and I am sure it would have really encouraged and benefited for all our participants watching from different platforms to know more about the expansion of Homo sapiens in Thar Desert. This talk has created a path for researchers, scholars to research in this field. Thanks a lot, Dr. Blinkhornji. I would like to thanks to our organizing committee and both circles, Maharashtra Circle and Assam Circle of Heritage Society, for giving me opportunity to chair the today's memorable distinguished session. Thank you all. Hmm?
Thank you, sir. Uh, Thank you so much, sir. I may now request Sonal Dhikle ji to present vote of thanks.
Good evening. I am Sonal Digle from Maharashtra Circle, and it's my privilege to have been asked to propose the vote of thanks on this occasion. I may like to express our sincere thanks to our distinguished speaker, Dr. Jimbob Blinkhorn, for taking his time out to deliver such a wonderful lecture. I would like to thank Mr. Azad and Gulshan Nanda for moderating this session, and Dr. Astha Dibyopama ma'am for presenting the welcome address. I would also like to thank Dr. Anantashutosh Dwivedi sir for organizing these lecture series and all the officers and members who have directly and indirectly contributed in making of this live session. Finally, I would like to thank all our members and viewers for joining this lecture today. Thank you.
Thank you, Sonal ji. I may now seek permission from our Honorable Chairman, sir, Dr. Anantashutosh, sir, for
Please,
the closing of the session. Thank
please.
you, sir.